What if you could control your Arduino directly from your phone? No wires, no internet, just Bluetooth? In this lesson, I will show you exactly how to do that using a Bluetooth module called BlueNoB. By the end of this video, you'll be able to turn an LED on and off wirelessly from your phone. And by the way, if you are new here, welcome! This is lesson 22 of a 24-part series called Arduino for Beginners. Alright, let's get started. Bluetooth is a short-range wireless technology that allows devices to communicate without cables. You've probably used it before with wireless headphones, speakers, or even your car. In simple terms, Bluetooth lets two devices exchange data using radio waves over short distances. There are two main types of Bluetooth: Bluetooth Classic and Bluetooth Low Energy, also known as BLE. Bluetooth Classic is designed for continuous data streaming. That is what you'll find in things like audio devices. Bluetooth Low Energy, on the other hand, is optimized for low power consumption. Instead of sending data continuously, it sends small packets of data efficiently. That makes it perfect for embedded systems like Arduino projects, sensors, and IoT devices. In this lesson, we are going to use BLE. More specifically, we will use the BlueNoB, a Bluetooth Low Energy module designed to work with Arduino. This module is compact, easy to use, and designed to consume very little power while still providing a reliable communication range. In practice, you can expect something around 20 meters indoors and even more in open spaces. One of the best things about this module is that it behaves like a serial communication device. That means it communicates with your Arduino using the same serial interface you've already used before. So instead of dealing with complex Bluetooth protocols, you just send and receive data using serial.read and serial.write. It also supports AT commands, which allow you to configure things like the device name or baud rate. There is a small switch on the module for that. When it's set to programming mode, you can send AT commands. For this project, we won't need that, so keep the switch in normal mode. If you want to explore that later, I definitely recommend checking the official documentation. Alright? That is enough theory for now. Let's build something. Before we move on, a quick thank you to DFRobot for sponsoring this video. DFRobot is a well-known provider of open source hardware for makers, students, and engineers. On their website, you can find everything from Arduino compatible boards and sensors to robotics kits and development tools. For this series, they provided the Mind Plus Arduino Coding Kit, a set of components designed to help beginners get hands-on experience with electronics and programming. If you want to follow along with these lessons more easily, I highly recommend checking it out. It's a great way to practice what you are learning here. You will find the link in the description below. Thanks again to DFRobot for supporting this series and helping make STEAM education more accessible. Now let's get back to the project. In today's project, we are going to connect our phone to our Arduino using Bluetooth and control an LED wirelessly. Here's what you need: Arduino Uno, input-output expansion shield, BlueNoB module, one LED, and one jumper wire. Start by attaching the input-output expansion shield to your Arduino, then plug the BlueNoB module into the appropriate socket on the shield. Next, connect your LED to digital pin 2. Once everything is connected, go to the GitHub repository for this series, the link is in the description, and download the project called Control LED. Open it in the Arduino IDE and upload it to your board. This code listens for characters sent over serial communication. When it receives the letter A, it turns the LED on. When it receives B, it turns it off. Now let's move to the mobile app. Inside the same folder, you will find two files, controlled.apk and controlled.aia. The .apk file is the Android app ready to install. The .aia file is the MTip App Inventor project, which you can open and modify if you want to customize the app. For this video, we will use the APK directly. Transfer it to your Android phone and install it. You may need to allow installation from unknown sources. Once installed, open the app. Make sure Bluetooth and location are enabled on your phone. These permissions are required for Bluetooth Low Energy scanning to work properly. Then tap on Start to Scan. The app will begin searching for nearby Bluetooth devices. After a few seconds, you should see a list of devices. Look for the one called BLE link. that is your Arduino B module. Tap on it to connect. If everything works correctly, the status in the app will change to connected, and you also see an indicator LED on the module turn on. Now for the fun part, tap the turn on LED button. Your LED should light up. Tap turn off LED and it should turn off. What is happening here is simple. The app is sending a single character over Bluetooth, and your Arduino is reading that character through the serial interface and acting on it. If you disconnect from the device and try pressing the buttons again, nothing will happen because the communication link is no longer active. And that's it. You now have a wireless control of your Arduino using Bluetooth. Over the past few weeks, I've received messages from many of you asking for help with your own project. So I decided to open a consulting service. If you work on a project and feel stuck, whether it is hardware, code, or system design, you can book a one-on-one session with me. We will go through your project together, identify the issues, and I'll help you move forward with a clear plan. If that sounds useful to you, check the link in the description and book a section. And that's it for today's video. You'll learn how Bluetooth Low Energy works at a basic level, and most importantly, how to use it with Arduino to control something wirelessly from your phone. Now here's a challenge for you. Instead of just sending commands from your phone to the Arduino, try doing the opposite. Connect the sensor to your Arduino, send that data back to your phone, and display it in the app. This is how real IoT systems work. Devices collecting and exchanging data. If you try that, let me know in the comments. If you enjoyed this video, don't forget to subscribe so you don't miss the next lessons in this series. And before you leave, I recommend watching the video that's on your screen right now. It will help you build even stronger Arduino projects. Thanks for watching, and I'll see you in the next one.